Okay, today we're going to discuss something called the HL theorem, which stands for the hypotenuse leg theorem. So first let's review the parts of a right triangle. And if we look at a right triangle, we should all know that across from the right angle and the longest side of a right triangle is the hypotenuse. And the two sides that make up the right angle are called legs. Okay? So here's how the hypotenuse leg theorem works. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So here we see two right triangles. Uh, we have the hypotenuse of one triangle congruent to the hypotenuse of another, and the two legs, one pair of legs, are congruent. So these two triangles are congruent by the HL theorem, hypotenuse leg theorem. Okay, so this is just another way to prove triangles congruent, but it's specific to right triangles. So here's an example, okay? We're going to see if these triangles are congruent by the hypotenuse leg theorem. Now we need three things to happen, okay? Number one, we have to have right triangles. Number two, we have to have the hypotenuses congruent to each other. And number three, we have to have one leg congruent to another leg. All right, so let's go through our checklist here. Right triangles, we have two right triangles, and the hypotenuse is congruent. Well, they share the middle side here, so this is congruent to itself by the reflexive property. So that would be the hypotenuse congruent to the hypotenuse. And we have two legs congruent, so these two are congruent by the hypotenuse leg theorem. Let's try the next one. Okay, again, right triangles, check. Hypotenuse congruent to the hypotenuse. And the reflexive property again allows us to say that these two legs, which they share, are congruent. So these are congruent by the hypotenuse leg theorem. All right, let's kind of put this all together and do a two-column proof here. So what we're given is WJ is congruent to KZ, and angle W and angle K are right angles. So let me put right angle boxes in there. Okay, and we're going to try to prove that these two triangles are congruent. All right, so statement one would basically be the given. So WJ is congruent to KZ, KZ, and angle W and angle K are right angles. Okay, and that reason was given. All right, that's given information. Now remember, we need to try to do three things here. We need to say that we have right triangles. We have to prove the hypotenuses are congruent to each other. And we have to prove that the legs are congruent to each other. All right, so what's given, okay? WJ and ZK are the legs. So we have step 3 done here, okay? That's all we have, really. We don't have anything stating that we have right triangles, and we don't have the hypotenuses congruent yet. So let's go ahead and see if we can figure this out, okay? Now, since these two angles are right, all right, by the definition of right triangles, any triangle with a right angle says that the triangles are right. So I'm going to use that as step 2. Triangle JWZ and triangle ZKJ are right triangles. And that's by the definition of right triangles. Okay, so we got our right triangles checked off. Step 3, we still have to get the hypotenuses congruent to each other. Now I know these two triangles share the side JZ, so I know that JZ is congruent to itself by the reflexive property. So there's my next step. JZ is congruent to JZ, and that would be the reflexive property. Okay, so we have our hypotenuses congruent. So it looks like we have enough for the hypotenuse leg theorem to work. So I can now prove triangle JWZ is congruent to triangle ZKJ by the hypotenuse leg theorem. So that concludes our lesson on the hypotenuse leg theorem.